Welcome to this M1 video on friction. So I'm sure you heard about friction before, but friction is just a force which opposes motion, and it's between two rough surfaces. So, for us, when we talk about a smooth surface, we talk about there being no friction. In real life, there's always going to be a small bit of friction. Even on, say, ice, there is a small bit of friction, but obviously, it is a lot less. And when we talk about smooth surfaces in mechanics, we mean zero friction. But when we talk about rough surfaces, then we talk about friction. Now, if I have a box like this box here, it's got a normal reaction to the surface, R, and it's got the weight pulling it down, which is mg in newtons. Okay, now if I apply no forces to this, then obviously it's going to stay stationary. Now, when I apply a force, say a horizontal force here, which I'll call P newtons, then what we'll find that happens is friction acts in the opposite direction, which I'll call F. Now, if P newtons is very small, it might not overcome the force of friction, so this block will still remain stationary. And P then, if I keep increasing P, it will get to a point where the friction then is at its maximum or its limiting value. Okay, and then any value above that, then P will start to move the block. So this will take it all the way up to F max, its maximum value, and then as P increases past that, then it will start to move this block in this motion, in this direction. And that's quite important to understand that, friction isn't a constant force. Okay, if P is small, friction, this block won't start moving to the left because the maximum friction value is larger than P. Okay, friction just acts equal and opposite of the force that is trying to cause motion. Okay, up to its maximum, and that then is the limiting value, and after which the block will start to move. Now, how do we find this maximum value? Okay, well, it's quite easy. We use the formula F max equals mu times R. So mu is what's known as the coefficient of friction. And it's just a numerical value applied to basically like how rough the surface is. So the larger the value, the rougher the surface, so the more friction that will be created. Okay, and then R is the normal reaction that object has with the surface. And smooth surfaces have zero mu, therefore they have no friction. Okay, so that's like the basics behind it. Now let's look at a couple of examples of where we're going to use it. So here we have a block of mass 5 kilograms pulled along a rough horizontal surface by a horizontal force of magnitude 25 newtons. The coefficient of friction between the block and the floor is 0.3. So before I start to calculate anything, I'm going to draw a quick sketch. So this is the block. Now there's 5G going to be down, R is going to be up, I've got a horizontal force of 25 newtons, and then I've got a horizontal force this way of F for friction. Okay, so what I want to do is calculate the maximum magnitude of the frictional force. So first I want to resolve vertically. So that is just simply, it comes from F equals ma, but since the acceleration is 0, then this cancels, so it's just r equals 5g. So for this kind of thing, you can just simply state r equals 5g. Okay, but just be aware that it does come from F equals ma. So this will be 49 newtons. Okay, so now F max is mu r. Mu is 0.3 and r is 49. So times that by 0.3 and we get 14.7 newtons. So my maximum frictional value is 14.7 newtons. So say this was 14 newtons instead of 25, this block wouldn't move. Okay, because it has to overcome the 14.7 for it to move. And friction can be any value up to 14.7. 14.7 is its maximum or its limiting value. Now B is find the acceleration. So F equals ma. So we've got 25 minus 14.7 equals 5 times a. So 25 minus 14.7 is 10.3. Divide by 5. So the acceleration is 2.06 meters per second squared. Okay, and it's that easy. Okay, but there are questions which, you have to think them through a little bit. And this next example is a prime example of that. So I've got a particle of mass 2 kilograms, rests on a rough slope that is inclined at 30 degrees to the horizontal. Given that the coefficient of friction is 0.2, calculate the range of values for force P. So the range of values, so that's not one specific value in this case. So let's put on our information. So that is R, and straight down is 2G. Now I need to resolve these forces. So this one is 2G cos 30, and this one is 2G sine 30. And it tells us that this is at rest on the slope, so it's not moving. Okay, right, so first things first, we need to be able to find the maximum force of friction. Okay, and to do that we need to find the value of R. Now it's not vertically upwards, it's perpendicular to the slope is what we're doing. So R equals 2G cos 30. So 2 times 9.8 times cos 30 gives me 16.97. Now I'll store this as A on my calculator so I can use the full value. Now F max is mu R. Mu is 0.2 times 16.97. So times 0.2 and we get 3.39 newtons. And this therefore is B. Now we come to the part for the range of values of P. Now what you've got to think about in this case is that this weight of this object wants to pull it down the slope. So I'm putting a force P here. Now, if the motion is at its limit and about to fall down the slope, friction will be acting up the slope. And if P is larger, so it's about to pull the object up the slope, then friction will be acting down the slope. So those are the two scenarios that I've got to deal with. So scenario 1 is the friction's acting down the slope. So let's deal with that. So that will be F equals ma. There's no acceleration, so it's just the F values. So P minus 2g sine 30 minus F equals 0. This F will be F max. So P equals 2 times 9.8 times sine 30 plus my B, my F max. So P equals 13.2 newtons to 3 significant figures there. Now for scenario 2. So in scenario 2, F acts up the slope. So this time I've got P minus 2g sine 30 but plus that F equals 0. So P equals 2g sine 30 minus F in this case. So that's 2 times 9.8 times sine 30 minus B. And this one is 6.41 newtons to 3 significant figures. So this is my range of values from P. You know, it's between 13.2 and 6.41. So that's why there's a range of values in this case, because if P is only pushing a little bit, then friction is going to be helping it, okay, overcome that weight. And if P is pushing more, then friction will act the other way, helping the weight counterbalance it. Okay, so this particle will stay stationary anywhere between these two values, because friction at its maximum gives me these two values, and then in between them friction will adapt, okay, anything up to its maximum value. So hopefully you followed this example. I didn't find an example like this you know, in the textbook or on any of the past papers, but I do remember a question like this. I swear on a past paper, I just can't find it. Okay, so I haven't given you one of these in the questions to have a go at, but if you want to have a go at this, you know, just copy down the question, put it into ChatGPT and ask it to create you some more questions like it. Okay, otherwise, before we get into the questions, don't forget, if you found this video useful so far, hit that like button. If you're yet to subscribe, subscribe now. And if you are willing and able to help me out financially, then hit that join button. Okay, you can join for 1 month or longer, is totally up to you. Otherwise, let's look at the questions. So 5 questions for you to have a go at today. Question 1 is just like a straightforward warm-up question, and then 2, 3, 4 and 5 are all past paper questions. I'm not saying they're difficult, but they're past paper questions nonetheless. Okay, so pause the video now. Welcome back. Let's look at questions 4 and 5. And pause the video now. Welcome back. Let's now look at the solutions to these 5 questions. Okay, so part A here. First, we need to resolve vertically. So we get R equals 5G. So 5 times G is 49. So F max equals 0.4 times 49, or 19.6 newtons. Okay, state whether the object will remain at rest. Well, its maximum frictional force is 19.6 newtons. This is only 7 newtons. So friction will match that 7 newtons and this will remain at rest. So that was part A. Now let's have a look at B. So resolving vertically, we get R equals 10G, which is 10 times 9.8, or 98 newtons. F max is 0.4 times that 98. 98 times 0.4, 39.2 newtons. Now this is a little bit of a mistake on my part here, because what I haven't done is, this isn't the actual value of R, is it? Because of this force here. So what I've actually got to do is roll that back, get rid of that. It's quite an easy mistake to make, but I need to resolve this. So this is 48 cos 30, and this is 48 sine 30. So now when I resolve horizontally, I get R plus 48 sine 30 equals 10G. So 48 times sine 30 is 24. So we've got R plus 24 equals 98. So R in this case will be 98 minus 24, or 74 newtons. And it's very easy to make that error. So F max now is 0.4 times 74. So F max is 29.6 newtons. Okay, now that makes sense. Now let's look at what's happening. Is it moving? Okay, so 48 cos 30 gives me a value of 41 newtons. So it is going to move. So F equals MA, and we've got 48 cos 30 minus my frictional value, which will be the F max, equals 10A. So 48 cos 30 minus 29.6 gives me 11.969 divided by 10 gives me that the acceleration is 1.20 meters per second squared to 3 significant figures. Okay, it's 1.1969, so when we round up it's going to become 1.20. Okay, so that is part B, and that is of course one that we have to be wary about. Now we're on to part C. If I've got enough room, hopefully I have. So part C. So first of all, let's resolve this force. So 2g cos 40 and 2g cos 40 there. Now resolving perpendicular, we get that r equals 2g cos 40. Okay, F, obviously that's the friction, and that's just parallel with the plane, so that won't do anything. So 2 times 9.8 times cos 40 gives me 15.01 newtons. I'll store that as A because I'm going to use that value. F max is 0.4 times 15.01. So using the full value times 0.4, we get 6.01 newtons to 3 significant figures there. And again, I'll store it as B to use a little bit later. Now let's see what's happening. So 2g, oh sorry, this one, I put cos 40, it's sine, isn't it? Sine 40 there. So 2g sine 40 is 12.59 newtons, so it is going to be moving. So F equals ma. We've got 2g sine 40 minus F max equals ma. Oh, the m is 2 kilograms, so it equals 2a. So 2g sine 40 minus the value I stored in B, which is the maximum frictional value. I get 6.59 to 3 significant figures divided by 2, and I get that A is 3.30 meters per second squared to 3 significant figures there. Okay, so that is going to slide down the slope. So those are the 3 parts for question 1. Hopefully, you didn't make like the initial mistake that I showed you in B, okay, which is easy to do. And hopefully you got all 3 of these correct. Let's have a look at question 2. So we've got a particle of mass 0.5 kilograms sliding down a rough slope that's inclined at 15 degrees to the horizontal, and the acceleration is 0.25. Basically calculate mu. So I'm just going to quickly sketch what's happening. So we've got a particle, 0.5 g newtons that way. Normal reaction there. It's sliding down the slope, so friction is acting up the slope. Okay, so acceleration is 0.25. So what I want to do is first resolve the weight. So it's going to be that way and that way. So 0.5 G. Now the angle is 15 degrees. So 0.5 G cos 15 and 0.5 G sine 15. Okay, so what I can do here is I can work out R, and R is equal to 0.5 G cos 15, which is 4.73 newtons to 3 significant figures. And again, I'll store that as A to use later on. Okay, and my F max is mu R, or 4.73 mu. Now let's resolve down the slope. So F equals MA, that's what we use on all of these. So 0.5 G sine 15 minus my F max, which is 4.73 mu, equals 0.5 times the acceleration 0.25. So 4.73 mu is going to be equal to 0.5 times 9.8 times sine 15 minus 0.5 times 0.25. And that's going to be 1.14. Divide that by, we store this as A, and we get that mu is 0.242 to 3 significant figures there. Now let's look at question 3. So here we have a particle of mass 2 kilograms sliding down a rough slope inclined at 20 degrees. Force of magnitude P acts parallel to the slope and is attempting to pull the particle up the slope. So we've got, just do a quick sketch, we've got a slope, we've got a particle of mass 2 kilograms. Now it's at 20 degrees and force P is attempting to pull it up the slope. Okay, now the acceleration of the particle is 0.2 down the slope. So the acceleration is 0.2 down the slope. That means that it's moving down the slope. So that means that friction is also acting up the slope. So if both friction and the force P is attempting to pull it up the slope, but it is moving down the slope. Now we need to resolve the 2G. So this will be 2G cos 20 and 2G sine 20. So first resolve perpendicular to the slope. So R equals 2G cos 20. So F max will be mu, which is that given to us? Yeah, 0.3 times 2G cos 20. So 0.3 times 2 times 9.8 times cos 20. And this is 5.53 newtons to 3 significant figures. And again, I'm going to store it as A so I can use the full value in my calculations. Now let's resolve parallel to the slope, and it's obviously going down because it's accelerating down the slope. So 2g sine 20 minus p minus f max equals 2 times 0.2. Okay, so 2 times 9.8 times sine 20 is 6.703 minus A minus 2 times 0.2. So rearranging this, P is 0.778 newtons to 3 significant figures. And there we have question 3. Fairly easy, I think, so far. Let me know in the comments what you think. Anyway, question 4. So in this question, we've got a sledge of mass 10 kilograms being pulled along a rough horizontal plane by force P that acts at an angle of 45 degrees to the horizontal. The coefficient of friction is 0.1 and the sledge accelerates at 0.3. So this is my diagram. I have R on it. The downward force will be 10g. It's accelerating 0.3. So friction is going to be acting that way. So first of all, I want to resolve vertically. So R equals 10g or 98. And F max is mu 0.1 times 98. So 9.8 newtons. Now again, I've made a mistake here because I've jumped ahead doing this and I haven't resolved my forces for P, because P is going to act up and across. So this is P cos 45 and this is P sine 45. Okay, and that I have to be careful of. So starting again, R plus P sine 45 equals 10g. So R is 98 minus P sine 45. Now sine 45 is 1 over root 2 or root 2 over root 2 over 2. So I will put that in as root 2 over 2p. Now F max is going to be 0.1 times R. Okay, so I'll leave it like that at the moment, but let's look at now resolving horizontally. So F equals MA. Now going horizontal, we got P cos 45 minus F equals 10 times 0.3, which is the acceleration, isn't it? So 10 times 0.3 is 3. Cos 45 is 2 root 2. So we got 2 root 2 P minus, and then we got 0.1 R. So the 0.1 R is going to be, if I rub it out, 9.8 not plus, is it? It's minus, and it's root 2 over 20p. Okay, so what I've done is I've times 0.1 by r, so 0.1 pi times 9.8, and times by this. Okay, which is times by 0.1 is basically dividing by 10. So root 2 over 2 plus root 2 over 20, because there's two minuses there, give me 11 root 2 over 20p equals, and then the minus 9.8 to the other side plus the 3 is going to be 12.8. So 12.8 divided by my answer here, and I get P is 16.4563 and so on. So P is 16.5 newtons to 3 significant figures there. Now with this one, there was another way of doing it. Basically because sine 45 and cos 45 are the same, we can create two equations and basically equate them, eliminating the p's and finding a value for r, and then using that r. So I'll show you kind of that now. So I could have done P is cos 45 minus 0.1 r equals 3, and equation 2 and equation 1 here. Okay, so when I kind of add 1 and or subtract 2 from 1, so 1 minus 2, I get r minus 0.1 r minus 0.1 r is going to be 1.1 r. Okay, so it's r minus this. P sine 45, take with P cos 45 as 0. And then 10g, which is 98, minus 3 is going to be 95. Divide by 1.1. And R is 86.36 newtons there, the two decimal places. And then store that as A. So we've got that in our calculator. And now I've got R. I can find P from equation 1. So from 1 or from 2. Doesn't really matter. Actually, I'll do it from 2. So from 2 we get P cos 45 equals 3 plus 0.1 r. Okay, so times this by 0.1 plus 3. So P cos 45 equals 11.64, just rounding off there. So divide that by cos 45 and we get that P is 16.5 newtons to 3 significant figures, the exact same answer. So because the cos and sine of 45 are both the same, I could have done this by finding r first and then found P that way. So two different ways in which you could do it. Okay, final question. We've got a train of mass m travelling at 20 meters per second when it applies its brakes, causing the wheels to lock up. The train decelerates at a constant rate, coming to a complete stop in 30 seconds. By modelling the train as a particle, find the coefficient of friction between the wheels and the train track. So first of all, we can find the acceleration. Because u is 20, v is 0. The time t is 30 seconds, and a is what we want to find. Okay, so v equals u plus at. 0 equals 20 plus 30a. So 30a is negative 20, a is negative 2/3 meters per second squared. So we've got the acceleration, okay, or the deceleration in this case. Now next we have to work out the coefficient of friction. So if you think about what's happening, we're modelling the train as a particle. It's moving in this direction, okay. It's obviously acceleration will be in the opposite direction. But friction is going to be moving in the opposite direction of the movement. We're going to have this as R and this as mg. So friction, the maximum friction is mu times mg. Okay, and then we've got F equals ma. Now, if I take the direction of motion as positive, then F is going to be negative, isn't it? Minus mu mg equals m times by minus 2/3. Okay, so the negative signs don't really matter, but the m's will cancel. Then mu g equals 2/3. So 2/3 divided by 9.8. Mu is 0.068. Two significant figures here. Or I could write it as 2/3g. Okay, so that is mu for part A. Now, for part B, it says the train is no longer modelled as a particle, so the effects of air resistance can be taken into account. State with a reason when using the revised model whether your answer to A will increase or decrease. So let's look at what we were doing with F equals ma, and let's take left as positive this time because it didn't really make sense to take right as positive. But friction was mu times mg, wasn't it? Now this time we're adding air resistance to that, and that's going to be m times a, which is 2/3. Okay, so this time we're going to go with mu mg equals 2/3 m minus a. So mu equals, divide by the mg, we get 2/3g like before, but we get minus a over mg because we're dividing by this mg. So this is the same value as before, but we've also got minus now this value, which is the air resistance divided by the mass times gravity. So this is smaller than this. Okay, so 2 over 3g minus a over mg is smaller than 2 over 3g. So now I can say that my answer to part A, my mu, will decrease. So coefficient of friction will be smaller in the second model. Okay, and just something like that to finish it off. But this will be sufficient for your reasoning. Anyway, that brings the end of this video and also the end of this chapter if you're following through with your textbooks. Next we'll be looking at momentum and impulse. So stay tuned.